In chemistry, when we learn about mole ratios, some students get a little bit confused. And so I have another relationship here that may help us to understand this a little bit better. And this is not an actual chemical reaction, but instead it's the process for putting together a peanut butter and jelly sandwich, something that most of us have seen or eaten. And so in this example, we have 1 scoop of peanut butter and 1 scoop of jelly, that's the 1J, and 2 slices of bread are all put together to make 1 peanut butter and jelly sandwich. And so that's the process. So if we decide that we want to make 30 sandwiches, well, we know that we're going to need how many scoops of peanut butter? Well, it's 30, isn't it? 1 scoop of peanut butter for each sandwich. That's a 1-to-1 ratio. And hopefully you see that we also need 30 scoops of jelly, a 1-to-1 ratio. But how many scoops, or rather how many slices of bread are we going to need? Well, I hope that you realize that since it's a 1-to-2 ratio of sandwiches to bread, we're going to need 60 slices of bread. So it's 2-to-1 bread to sandwiches. Now let's say that we eat all these sandwiches and we decide to actually go into business, and we start to make maybe thousands of sandwiches, and we decide that we're going to make a factory. And so we have maybe a truckload of peanut butter to make these sandwiches, and we're going to have a truckload of jelly, a huge amount, but for some reason we only have 4 slices of bread. So we have a huge amount of peanut butter, a huge amount of jelly, but only 4 slices of bread. How many sandwiches are we going to be able to make? Well, I hope you realize that we're only going to be able to make 2 sandwiches. And that's because we're limited in our ability to make the sandwiches, because we only have 4 slices of bread. And so in our example there, since we ran out of bread first, in chemistry we call that the limiting reagent. The limiting reagent, or sometimes called the limiting reactant, is the reactant that runs out first in a chemical reaction. So in chemistry, we're usually not trying to make sandwiches, we're usually trying to make some sort of a product. Maybe it's an acid, or maybe it's oxygen gas, or water, or some other substance. Well, we know that in the 2 or the 3 reactants we have, one of them is going to run out first, just like our bread ran out first in this example. So that's the limiting reagent. And another way of thinking about that is saying that it's the reactant that produces the least amount of product. So for example, with the truckload of peanut butter, maybe we could have made 10,000 sandwiches. Or with the truckload of jelly, we could have made 10,000 sandwiches. But since we only had 4 slices of bread, we were only able to make 2 sandwiches, and that's why we call bread the limiting reagent. Now, after you make those 2 sandwiches, you're going to have a whole lot of peanut butter and jelly left over. That's excess, and so we call that the excess reagent, or sometimes the excess reactant. And that's what you have left over at the end of a reaction. So in a reaction we have limiting and then excess reagents. So let's try an example here. We have a balanced equation, and we're going to have a problem here. And it says when 54.0 grams of aluminum is reacted with 36.0 liters of oxygen gas at STP, how many moles of aluminum oxide can be produced? Well, notice that this problem is different from the problems we had in our previous lesson, because we're given 2 reactant values. We're given 54 grams of aluminum, and we're also given 36 liters of oxygen. And the question is, how many moles of Al2O3? So we have to start by writing down both of those beginning values, 54 grams of aluminum and the 36.0 liters of O2. And we're going to take both of these and convert both of them down to moles of aluminum oxide, Al2O3. So that means we're actually going to have to do our three-step process twice. If you need some review with the three-step process or don't know what that is, you might want to look at the previous lesson. Now the first step, we'll start with the first process here. The first thing we want to do is convert that to moles. That's always the first step, convert to moles. So moles on top, grams on bottom. And how many grams are in a mole of aluminum? Well, we have to look at the periodic table. We see it's about 26.98, so we can round that to the nearest tenths place and say about 27.0. Grams cancel. We're now in moles of aluminum. Step 2 is the mole ratio. So we need to put aluminum on the bottom so it will cancel, and then aluminum oxide on top. And the coefficients come from the balanced equation. It looks like it's a 2 to 4 ratio. We have 2 and 4. And so aluminum cancels. We now have moles of aluminum oxide. We want to be in moles of aluminum oxide, so that's all we have to do. Now we can multiply and divide. 54 times 1 times 2 divided by 27 divided by 4. And the answer I'm getting is about 1.00. Now we have to do the three-step process with the other reactant as well. So the first step here is to convert that to moles. So 1 mole on top, and 22.4 liters will go on the bottom, and liters can cancel. Second step is the mole ratio. So it looks like O2 needs to go on the bottom, and Al2O3 goes on the top. So that's what we're converting to. And do you see what the mole ratio is this time? It's 2 to 3. Let's use those coefficients from the balanced equation. So oxygen cancels this time. We're in moles of aluminum oxide. That's our desired unit. So we just punch that into the calculator, and we get an answer of about 1.07. So that's the other answer. Now we have two possible answers, and we can't really have two answers to this problem. We can only have one answer. So in a limiting reagent problem, we always go with the smaller number. So we take the smaller number and select that. And so the answer is 1 mole of aluminum oxide. Now if we go back here to the beginning, the reactant that produces that smaller amount, which is aluminum in this case, is the limiting reagent. And so that means that aluminum is what's going to run out in this problem. And then the reactant that did not produce the smaller amount, the oxygen in this case, is going to be the excess reagent. And so we'll have oxygen left over. Let's try another example. This time we're going to try this balanced equation. We're going to make some water with 2 moles of hydrogen and 1 mole of oxygen. And this time the question asks, if we react 10.0 grams of hydrogen with 10.0 grams of oxygen, how many grams of water will be produced? And so once again, we're given 2 amounts of the 2 reactants. So we start with 10 grams of hydrogen, H2, and the 10 grams of oxygen, O2. And we're going to take both of those reactants and convert them down to grams of H2O, way down here at the end of the process. And so essentially we're going to have to do this problem twice, or do the three-step process twice. We're going to get 2 answers, and we select the smaller one, just like we did earlier. So in the first process here, we'll go through the 3 steps. Step 1 is convert to moles. So moles on top, grams on bottom, and the number of grams in a mole of O2. Well, H has an atomic mass of 1, but we have H2, so it's actually 2 grams in a mole of that. So grams cancel. Next we do the mole ratio. So H2 on the bottom, hydrogen, and water goes on the top. You see the mole ratio? It's a 2 to 2 this time. So hydrogen cancels. We now have moles of water, and we want to be in grams of water. So we have to do step 3 this time, which is convert to final unit. And our final unit is grams. So grams on top, 1 mole on bottom. And how many moles, or rather how many grams are in a mole of water? We have to use the atomic masses. 1 plus 1 plus 16 is very close to 18 grams. So we cancel moles. And we do the arithmetic here. 10 times 2 times 18 divided by 2 divided by 2 again. And the answer I'm getting is about 90. 90 grams of water. Now let's do the next process and see if that number is larger or smaller. So once again, we have to convert to moles. Grams on bottom, moles on top. And for oxygen, it's 16 times 2, so that's 32 grams in a mole of oxygen. Grams cancel. Step 2 is the mole ratio. So oxygen goes on the bottom this time, and water goes on top. And do you see the mole ratio? This time it is a 2 to 1 mole ratio. Oxygen cancels. Now we do step 3, which is convert to our final unit, which is grams. So moles on bottom, grams on top. And once again, it's 18 grams in 1 mole of water. Canceling out moles. I strongly recommend that you cancel out the units as you go along, so it's obvious to see what's happening in your problem. I also strongly recommend that you write the units. Don't just leave those out. That's a very important part of this problem. When you do the arithmetic on this, I'm getting an answer of about 11.25 grams of water. So we have 2 answers. Which one is the correct answer? It's always the smallest one. So it's 11.25 grams of water. And the reactant that produced that smaller number, which was O2, oxygen, is our limiting reagent, or our limiting reactant. And then the H2, I've crossed it out so it's kind of hard to see there, but H2, hydrogen, is what's left over. That would be our excess reagent, or our excess reactant. So after doing these problems, hopefully you can see the process that we use to solve limiting reagent problems. We have to continue using our 3-step process, and we'll have 2 answers, and the smaller of those 2 will be the correct answer.